Good morning. I'd like to thank the conference for having me. Today I'll be presenting on the detailed characterization of odors specifically with volatile organic compounds and reduced sulfur compounds. Yeah, thanks. So just a little background on myself. I'm with Airzone 1, and we're an environmental consulting company, and those are some of our services we offer. And today I'm going to be presenting specifically on the analysis and the sampling methods. So odor characterization. Often, you know there's an odor present, but it doesn't tell you the full story about what that odor is composed of, where it's actually coming from in certain cases. So sometimes it's very important to actually go in a little deeper and characterize the odor and look at specific concentrations of specific compounds. And again, the focus today that I'll be talking about is RSCs and VOCs, but there's also other compounds that you can consider. So it's very important to look at your sampling methods before you dive into something like this. With RSCs, or reduced sulfur compounds, it's a little bit more limited, and it's more complicated because you really need to get the samples back to the lab quickly because the samples degrade. And in certain cases, we'll actually go on site and set on our equipment on site. And as soon as the samples are collected, we can analyze them there and have a quick result and also ensure that none of the samples are degraded. So generally, if we're looking both at integrative and grab samples, you can use a treated canister, something like a sulfonert cylinder. And you could also take grab samples using Tedlar bags or flex foil bags, depending on what's easiest in the situation. And the two types of analytical methods that are generally used for RSCs are GCFPD and GCSCD. If you move into VOC sampling, you usually have more choices here in what you can do. And it'll differ if you're going to do an integrative sample over a longer period or if you just want to do a grab sample. With integrative sampling, you can use something like a passive device, which is there on the left, and then or tubes with a sampling pump with some sort of sorbent. You can also use a Summa canister. Summa canisters are generally used because people are more familiar with them, and it's a historical type of sampling method. But the other two also have their benefits, which I'll get into later. And again, with a grab sample, you can use something like a Tedlar bag or, again, Summa canisters. If you look into the analytical methods, you can do GCFID or GCMS. Usually I would favor mass spectrometry because it gives you more accurate data, and you can also look at scan data, so you can look at non-target compounds rather than just a target list, because there may be compounds there that you might not be looking for and could really provide some useful information. So I'm going to go into some more detail with comparing these methods and which one you would choose. So I actually like a Summa canister. It's big and bulky, and if you have to do multiple samples, you're carrying them around and could get a little cumbersome. If you look at something like a passive sampling device, it's quite small. You can and comes with a little clip and can be clipped on a fence line somewhere. And really, anyone can use it. You pop off the top, there's a membrane, you record the time you set it out, then you go off whatever amount you want to sample for, and then you retrieve it, put on a elution cap, and then you can ship it to a lab, and they're quite small, easy. But, if this won't work for a grab sample, so it's an integrative sample over a longer period of time. You can also look at something with like the sorbent material, so you've got a pump. This is a little bit more cumbersome because you're going to have to calibrate this pump. It's a little bit more work. But again, also has its advantages. So some of the other advantages are with a sorbent tube or a passive sampler. If you get into a very odorous situation, if you're sampling with a Suma canister, if you overload that canister, it won't be able to be cleaned, and you're going to have to pay for that canister, and it could get quite expensive. Whereas if you're looking at a passive sampler or charcoal tube, that's disposable, so you're not incurring that cost. So it is valuable to look at that if you're looking at very high concentrations. Generally, all these methods are accepted by regulatory bodies, depending on the application, of course. And again, I mentioned you won't be able to do grab samples with sorbent materials. You'll have to look at something like a Suma canister or a Tetlar bag. So I'm just going to go into some examples now of some of the applications where what you actually do with this data that you now have. So if you look at reduced sulfur compounds, often, well, not often, always, it's added to natural gas. So there's specific mercaptans such as terbutyl-mercaptan and isobutyl-mercaptan that are added to natural gas as an odorant, so you can detect leaks. And sometimes there'll be cases where people are reporting a possible leak because they have the slight sulfur odor, but it may not be apparent where this leak's coming from, so you really need to verify, is it really a leak or is it something else? So in this case, you can do a detailed breakdown of all the different RCs. So on the right there is a chromatogram of a complex mixture of RSCs. So a lot of the time what ends up happening is, well, it's not really an odorant that's added to the natural gas. It'll be something like hydrogen sulfide, which does have a slightly different odor, but in low levels, it could be hard to differentiate. So it could, in that case, it could be that it's really a sewer gas. But another issue is that the detection limits of reduced sulfur compounds are often not in tune with our noses. So you can actually smell hydrogen sulfide, but you won't be able to detect it using any analytical method. So you can look into analyzing other components, such as hydrocarbons, that are present in natural gas, and seeing if you can look at those, like methane is going to be definitely a lot higher and a lot more detectable. And then you can look at some of the smaller components, such as ethane, propane, and the butanes. So it's really important to maybe sometimes not even look at your specific odor, but other tracers that may be also present in that mixture, which may or may not have an odor. Like methane doesn't have an odor, so you really have to look at other components. My next example is going to look at worker exposure and odor complaints. So a lot of the time in work environments, people are working with various products, and really the only time you really hear a complaint about working conditions a lot of the time is there's some sort of odor present, and it may or may not be obvious where it's coming from. If it's an office situation, it could be something like mold. If it's an industrial facility, then it might be more obvious because you'll know what chemicals you're working with. So in many cases, the odor threshold is actually way above what a regulatory limit is. So just because you smell it doesn't mean that there's some sort of health risk within that facility. So it's important to look at first what the possible sources are, and then develop a plan to actually find out what's going on within that facility. So this particular situation, there was an odor complaint at a facility, and it was generally in the area where there was paint application being done, but there's other things that are being done at this facility as well. So you look at the MSDSs, but they don't always provide too much information because with paints and other products, a lot of the time they withhold certain compounds due to proprietary information. So you can look at an MSDS and decide, oh, you're going to analyze for specific compounds, but it really is sometimes important to ask for a VOC scan analysis, which is going to give you a full picture of what's present. So when you do that, again, you can look at odor thresholds with your analysis results along with the regulatory limits. So you can find that you've identified specific compounds that are over the odor threshold. So yes, it most likely is this. And then look, oh, okay, it is over the odor threshold, but still below the regulatory limit. And in Ontario, that would be OREG 833. So these are actual results. So there were 2 samples taken. One was the employee actually wore the sampling pump, and the second was just done generally within the area because the employee moves around, so closer to the actual application of the paint. And in general, these are the results. They're all in milligram per meter cubed. Here we have the Ontario regulation values and the odor threshold. So you'll see in most cases, they're actually a lot higher than what we can smell. And what we found was that this one compound was most likely contributing to the odor complaint, but that there were a lot of other VOCs present. This is only actually a select portion. There was a lot more different VOCs present. So it could also just be the combination of all of the VOCs. But the important thing to note was that all of the results were below the regulatory limits. So what's the takeaway here? Well, it is important to know that there is an odor there, but sometimes it's also important to actually go in and characterize so we can see what's going on with the situation and how serious the issue is, because if, it's one thing to have an odor, but it's another issue to have an actual health risk for an employee or a population. And before you actually go in, you might want to look at what the regulatory limits are for certain compounds that you're interested in, to look at the sampling time. And then from that, you can pick the best sampling method for your situation, and then you can go on and interpret the data. Thank you. Questions?